Hello, everyone. This is Qin speaking. So I'm a technical support engineer in SuperMap International. Today, I'm glad to be here to have a presentation about evolution of new generation 3D GIS technology. In this presentation, you are going to learn about the latest progress of SuperMap 3D GIS technology. So firstly, why we need to develop 3D GIS technology? As you know, 3D GIS can better present the real world. As a 3D digital CNC, it is increasingly used in many industries, just like the 3D real scene construction, city information model construction, and smart park construction. They are combined with BIM and GIS or 3D model and GIS, which shows that we need to constantly develop 3D GIS technology to better serve industrial applications. So as to meet the industrial needs, SuperMap has made some progress in 3D GIS technology. Today, we will learn them from these 5 aspects. So firstly, let's go to the first section, the progress in spatial data modeling. After more than 10 years of development, a new generation of 3D GIS technology has gradually built a 2D and 3D integrated data model to express the full space, including object model describing discrete spatial features, and network model that describes the connection relationship between objects, as well as field model describing continuous distribution phenomena in space. And with this spatial data model, we provide 3D spatial analysis such as flatline analysis, dynamic wheel-shape analysis, and skyline analysis, which based on object model, and 3D contour analysis, 3D slope and aspect analysis based on field model. At the same time, we can get the analysis results to better assist the industrial decision making, such as urban planning and design. In addition, we also provide a 3D spatial query. It supports indoor and outdoor real-time spatial location query and large amounts of data real-time spatial location query. This playing an important role in BIM.GIS, CRM, and other industrial applications. Except the 3D spatial analysis, we also provide many analysis operators for different models. For 3D surface model, including the mesh model generated by surface modeling tools such as 3D Snacks, and the mesh mode generated by Oblique photography automatically modeling tool, as well as the terrain tiles model. We provide a variety of analysis operators for this data, which is convenient for developers in multiple industries to achieve data aggregation and fusion, and support more in-depth 3D GIS applications. For topological closed 3D volume models, such as BIM, we provide Boolean operation, 3D spatial relationship judgment and query, and dimension reduction operation, and others like convex hull calculation, 3D buffer, and so on. These operators help urban design to form digital rules and improve urban governance. In addition, we can also use parametric representation to express 3D volume models. We can create simple geometry such as sphere, ellipsoid, and cuboid by parametric test equations. We can also use the point line and region data to build 3D volumes through modeling operators such as section opting and stretching. In the design software, the commonly used constructive solid geometry can build more complex and real 3D objects through multiple Boolean operators, such as intersection, union, and subtraction. So we can make the solid a complex model. Then let's take an application. The traditional underground roadway modeling is mainly manual modeling in the model design software, but due to the complexity of the terrain and frequent data updates, repeated manual modification of the model greatly affects the efficiency of the data display. However, we can quickly build the underground roadway through parametric modeling based on the 3D center line of the roadway and lofting. It can also semi-automatically process complex connectivity of pipeline corridor and intersection based on the topological relationship of data. And the result can be supported to play on multiple terminals, such as a desktop browser or a game engine. For the processing of massive multiple source data, we also provide rich processing automation operators in the latest version, covering BIM and manual model, oblique photography, tintering, rural modeling, point cloud, and many other aspects. For example, this is a terrain data processing automation workflow. You just need to set the parameters like the path of terrain data. Cache setting includes path of cache file and the path of the aesthetic file. Then the terrain can be published as 3D services automatically. Then you can view the terrain on the browser. For oblique photography, it's the same. All of the processing steps can be done automatically. After setting parameters with the function, we can automatically end 3D data. Like in smart city projects, we don't need to manually process new data every time we add it, but users can directly add it to the system for management and sharing after collecting data. The BIM data can be accessed to GPA process from BIM software to realize automatic exports, cache generating, and BIM data publishing. We can also just need to set the parameters of the BIM data, and then we can also set the parameters of generating cache and then publish the imported BIM data. Then users can browse the published BIM data directly on the web. So let's make a summary. After continuous technical iteration, the spatial data model has formed a technical framework from model expression to 3D spatial analysis and query, and then to 3D spatial operation and processing, which has laid a foundation for the in-depth application of 3D GIS in the industry. Then let's take a look at the 3D data format S3M upgrade. Since year 2015, we launched S3M data format. It supports multi-source heterogeneous 3D geospatial data. such as oblique photography, point cloud, beam, and so on. It also supports efficient rendering of large-scale 3D data, objectified selection and query, and efficient transmission, visualization, and analysis capabilities. At the same time, it is a format that supports cross-terminal and cross-system application. In 2021, we launched S3M 2.0. It uses more advanced algorithms in geometry and texture. Meanwhile, it supports PBR materials for better display the objects. It also improves the structure and attributes of storage, which makes it possible to support the massive data management. In 2022, we upgraded the format to S3M 3.0. We have improved the performance in many ways. It supports mixed-up geometric compression and KTX2 texture compression to reduce data, but improve the download performance. It also supports OBB bounding blocks to achieve more accurate index scheduling. And it also supports skin and bone animation to provide more abundant scene animation effects. It also supports mask texture so as to provide beautification effects for the data like oblique photography. In addition, the mesh model supports more dimensions vertex attributes, so we can enhance the scalability of industrial application.
We made a comparative statistic. Through this improvement, the data capacity can be reduced by about 30%.
And the memory usage can be reduced by about 40%, and the loading performance can be improved by about twice as before when using S3M 3.0. Here are two demos showing that S3M can smoothly render a large amount of oblique photography data and wide model. Let's have a look at an example of storing multiple dimensional vertex attributes in water conservancy applications. The results of flooding analysis are stored in S3M multiple dimensional vertex attributes to dynamically express the flooding process. Let's see another example, how to make a light view effect for fine model or oblique photography. Combining mask texture and AI technology, we classify the objects of an entire building surface texture, then set different material functions to different channels of the classified results, so as setting self-luminous material effects on windows so as to achieve the light view of fine model. Then let's make a summary of the S3M characteristics. The S3M achieves expression ability of multiple source heterogeneous 3D geospatial data. It provides efficient rendering of global level large scenes.
And it provides hi-fi 3D data representation capability and animation effect.
It also supports object-based selection, query, and other real-time interactive functions. It also supports efficient analysis and application of desktop, browser, mobile device, and other multiple terminals. And it also supports flexible extension of materials, attributes, and semantic information to meet multiple industry applications. Third, we are going to have a look at the evolution of 3D web client technology. With the development of cloud computing, a large number of GIS business systems are deployed on the cloud. On the one hand, users have a demand for 3D visualization, and on the other hand, users prefer to combine visualization with GIS capabilities to build applications that can solve practical business problems. Based on these needs, we released the first 3D web client based on WebGL in 2016. This client includes system development packages. On this basis, we expanded the S3M layer and expanded more 3D GIS functions and coordinates developed the Vue components around the S3M layer. This year, we also made improvements. Developers can achieve 3D GIS application by using 3D GIS plugin of System and System open source packages. At the same time, for higher realism, rendering and massive data carrying capacity, we improved clients for WebGL for in-depth application. Through the latest WebGL engine, we can easily achieve the image-based lighting, night view, and rain slowing effects, as well as the slow cover and reflection in water effect. We also support the real-time shadow effect of following the sun's position under S3M layer. In addition, we can follow the time and the position of the sun, and based on the physical atmospheric scattering effect, truly simulate the atmospheric and the sky effect. At the same time, our client 3D for WebGL package provides multiple 3D spatial analysis, such as profile analysis, shadow analysis, and so on, so it can meet the needs of web application. In addition, the high-efficient rendering method can make you display 3D models through different ways. This is an apartment management system. You can view every floor and check its information by pulling out. Then let's talk about the evolution of 3D high fidelity. The 3D high-fi visualization is the result of higher requirements of 3D display. We provide Hi-Fi 3D GIS SDK, which can fusion 3D GIS and game engines like UE and Unity. The game engine can provide realistic and immersive 3D view. At the same time, this SDK provides spatial analysis to meet the application requirements of 3D large scene high realism rendering and spatial analysis capabilities. The development of 3D GIS and the game engine is from 2020. At the beginning, it can access to massive multiple source heterogeneous data and services. In 2021, we achieved more 3D spatial analysis and query functions. And in this year, we improved the 3D GIS data beautification scheme so make rendering more efficient. Then let's have a look at the progress of support for UE. In 2020, we provided 3D GIS development SDK for UE4. In 2021, we ended the support for UE5, and in this year, we launched product SuperMap Explorer 3D. It is a lightweight and ready-to-use 3D scene browsing software. We updated our game engine 3D GIS plugin SDK on the UE mode, which is comparable with UE5, and the number of downloads is more than 70,000. So we also welcome you to download it from UE more. The SuperMap iExplorer 3D is a lightweight and ready-to-use 3D browsing software, which is a desktop software developed based on SuperMap Hi-Fi 3D SDK and UE5. It supports massive multiple source heterogeneous data view, and also it supports Hi-Fi rendering engine spatial effects and supports cloud rendering and publishing to the web. It can flexibly set environmental parameters through the built-in interactive interface of the product, and combine the global lighting and post-processing capabilities of the game engine to create a more realistic 3D graphics base. Then we also have improvements in Unity. In 2020, we can just render pipelines in general. In 2022, we can fully support for URP to render the pipelines. Whether UE or Unity, we provide a variety of 3D spatial analysis, query, and layer interaction to help developers quickly call GIS functions in the game engine. We can also develop simulation application of real geographical scenes through oblique photography combined with physical collision. Multi-source data combined with physical engine can control parameters such as water flow direction, angle, and intensity in real time to support digital twin applications in multiple industries. With the development of game engine plugin, we can load S3M layer to the game engine and associate PBR material in the game engine, so can create 3D pipeline with metal texture. Let's look at the data of power stations. We improve the expressiveness of the whole thing through the latest beautification scheme. Use the Hi-Fi plugin to dynamically associate the material of UE to S3M layer in UE5, so we can achieve the self-illumination of the window and create the night view effect. And also we can simulate the weather, just like to simulate the raining or snowing. In addition, we can also explore PBR materials from UE to white model and load them by Acclaimed 3D for WebGL, so that we can more clearly feel the light and shadow effects of buildings and roads. Therefore, we can conclude that through the combination of game engine plugin and the web 3D engine, we can not only achieve higher realistic scenes, but also make them more valuable in commercial applications. Then let's go to the last part, the progress of 3D GIS technology and AR fusion. So the first is about virtual reality. As we all know, SuperMap at desktop has supported VR several years ago. So this year we have added a new supported device, Oculus Quest 2. At the same time, our game engine plugin also supports VR. In this way, we can browse the 3D GIS scene rendered by the game engine in VRS. Just like the video shows, we can view the Fuzhou-Xiamen Airport through VR, and the airport is rendered by UE. So then let's take a look at the pipeline application of AR and GIS. In the pastoral road construction process, due to the uncertainty of the location and the precise direction of various underground pipelines, the efficiency was affected and the traffic congestion was usually caused. So with the perspective ability of AR and GIS, we can easily check the information and as well as combined with the immersive experience and operable interaction, the distribution direction of each pipeline is very clear, which greatly improves the construction efficiency. Then let's talk about the mixed reality. Based on 3D GIS game engine development platform, so it is possible for you to immerse in climbing Mount Kumlama in the office. So we can make a summary. The new generation of 3D GIS technology supports geographic entity model, parametric model, and parametric modeling capabilities. And it provides new self-developed 3D WebGL client products to meet more in-depth application needs. And a 3D GIS plugin SDK supporting UE5 is added to realize high fidelity rendering of 3D geographic scenes. We also hope to support more in-depth 3D GIS applications based on the constantly improved technical system. So that's all for my presentation. Thank you for your listening.